Hi students, welcome back. Hope you are having good time. So in this part, we'll discuss about colligative properties. As I already told you, this topic is very important for all the competitive examinations. So in this part, we'll be discussing about the concepts related to elevation in boiling point, depression in freezing point and osmotic pressure. We'll see the different effects of non-volatile solute when it is added to a given solvent. So let's start this important topic. So in this part we'll be discussing about colligative properties. This is one of the important topic for IIT-JEE, AIPMT and also BITSAT. So let's start this part. Colligative properties. What are colligative properties? The first point you have to understand is that there are some properties of the solutions which do not depend on the amount and type of the solute, right? So there are many properties of the solution which do not depend on the amount of solute, but on the other side there are some properties which depend on the concentration of solute particles or amount of solute particles. So such properties which depend on the amount of solute particles or which depend on the concentration of the solute particles are called colligative properties. So colligative properties depend only on the concentration of solute particles but not on their identity. So what are these colligative properties? The colligative properties are freezing point depression, boiling point elevation and osmosis. So these are the few important colligative properties. First we will start with boiling point elevation. First let's go through this animation. So what is the analysis of that video? When you are adding a non-volatile solute to a given solvent, what was happening? The vapor pressure of the given solution was decreasing. So because of this decrease in vapor pressure, there is an increase in boiling point of the resultant solution. I am repeating again, when you are adding a non-volatile solute to a given solvent, the boiling point of the resultant solution increases. So that increase in boiling point of the given solution is called boiling point elevation. So the boiling point of the liquid is the temperature at which the vapor pressure of the liquid is equal to the prevailing atmosphere. So what is boiling point of any liquid? Boiling point of any liquid is that temperature at which vapor pressure of the liquid is equal to the prevailing atmospheric pressure. So this is first important point. So next important point, vapor presence of solutions containing non-volatile solute is lower than the vapor pressure of the pure solvent. This point we have already understood from the given animation. In the previous animation also, it shows that when you are adding a non-volatile solute, right, so the vapor pressure of the solution will be now lower than the vapor pressure of the pure solvent. This means that more heat will be required to raise the vapor pressure of the solution, right. So since earlier the vapor pressure of the solvent is Vp or V solvent, and because of adding a non-volatile solute, this Vs will be lowered, right, the vapor pressure will be lowered to V naught, right. So because of, since now V naught is less than Vs, right, so you need more heat to rise the vapor pressure of the given solution, right. So vapor pressure of the solution will be V naught and V naught will be less than Vs, which is the vapor pressure of solvent. So that means that boiling point of the solution will be higher than the pure substance. So because of this, because of this addition of non-volatile solute, the boiling point of the solution will be higher than the boiling point of the pure substance. So, mole boiling point constant Kb is nothing but the boiling point elevation of the solvent in 1 molar solution of a non-volatile non-electrolyte solute. So, there comes another important constant, molar boiling point constant, which is the proportionality constant. So, what I can say is that suppose you have that initial boiling point is T1, initial boiling point of the solvent is T1, because now you are adding a non-volatile solute, to the given solvent. Since the boiling point of the resultant solution is increasing to T2, this difference is called delta Tb, or the boiling point elevation. So, it will be T2 minus T1. So, this change or this difference is called boiling point elevation, or it is the difference between the boiling points of the pure solvent and a non-electrolyte solution of that solvent. So, this will be directly proportional to the molar concentration of the given solution. We have discussed about molality, and we know that molality is nothing but number of moles of solute, in a given amount of solvent. So, this is weight of solvent in kg. So, this boiling point elevation will be directly proportional to molality, and to remove this proportionality constant, there comes a boiling point elevation constant Kb. So, this will be now Kb multiplied by molality. What is molality? So, I can write this as delta Tb is equal to Kb into, what is molality? Molality is nothing but number of moles of solute. So, what is number of moles of solute? Weight of the solute by gram molecular weight of the solute, M1, and weight of the solvent, right? Weight of the solvent. So, it will be W2, and if it is in grams, it will be W2 by 1000. So, this is the boiling point elevation, right? So, when you are giving the mass of the non-volatile solute, you can understand the gram molecular weight, you can calculate the molecular weight of that non-volatile solute, and W2 will be the weight of the solvent. So, this is nothing but boiling point elevation for a given solution. So, we are discussing about a non-volatile solute. Now, what happens if this solute is an electrolyte, right? We know that any electrolyte breaks apart into ions, right? Any electrolyte, it breaks apart into ions. Each ion has an effect on boiling point and freezing point. We will be discussing freezing point in the next part. But what is important is that when you have an electrolyte, this electrolyte can be split into ions, and each ions will affect the boiling point and freezing point. So, if a solution has more or less ions, it will change the boiling point and melting points even more. For example, now you have NaCl. So, NaCl can be split into Na plus and Cl minus ion. That means you have 2 ions. So, if we have 2 ions, delta Tb will be now not only equal to Kb, it will be Kb, not only Kb into m, it will be again multiplied by n. N is again, it is the number of ions into which this electrolyte can be split. So, this is also important logic which we have to understand. So, if your non-volatile solute is an electrolyte, now change in boiling point will be now proportional to the number of ions, right? So, for example, MgCl2, it will split into Mg plus and 2Cl minus, or it will be 3 ions. So, now N value will be 3, number of ions will be 3. Fe2SO4 thrice, it will be having 2 and Fe plus 3 and 3SO4 minus 2, it will be 5 ions. So N will be 5. So boiling point elevation will be directly proportional to the number of ions into which this electrolyte will be splitted. Next important concept. Let's go through this animation. So this is a beautiful animation, right? So it describes that when you are adding a non-volatile solute like ethylene glycol to water, right, it is saying the effect of the freezing point depression. What is freezing point depression? Just like when you are adding a non-volatile solute to the given solvent, boiling point is increasing. In the above animation also, we have seen that there is a change in freezing point, that right, but the important thing is the freezing point of the given solution will be decreasing. Unlike boiling point elevation is increasing, the freezing point depression is decreasing. So molar freezing point constant is the freezing point. So just like you have a molar boiling point constant, you have a molar freezing point constant for 1 molar solution, right? So what is, first of all, we will go for the basic formula. The basic definition says that the freezing point depression delta T is the difference between the freezing point of the pure solvent and the solution of a non-electrolyte. So, and it is directly proportional to the molar concentration of the solution. So when you are adding a non-volatile solute to the given solvent, the freezing point of the given solution is decreasing. So this is known as delta TF or freezing point depression. This freezing point depression will be again proportional to the molality of the given solution or molar concentration of the given solution. So what you will get? You will get delta TF directly proportional to the molarity of the given solution. So what again you can write? The constant here will be Kf, where Kf is molar freezing point constant. So it will be Kf into m. So delta TF will be Kf into m. So the freezing point of 1 molar solution of non-electrolyte solute is found to be 1.86 degrees. Right. So this freezing point for 1 molar solution is found to be 1.86 degrees lower than the freezing point of water. So thus 1 mole of solute of 1 kg will be equal to 1.86 degrees centigrade. That is, if you write, for example, generally the solvent which you consider for this concept of colligative properties is water. Right, and water initial freezing point will be 0 degree centigrade, and if you want to know, right, the final freezing point, and because of the depression, so delta TF will be, remember, it will be not final minus initial, it will be initial minus final, this will be equal to Kf into molality. And when you are considering 1 mole or 1 mole of solute in 1 kg of solvent is nothing but it is 1 mole, and Kf it is found to be 1.86. Kf is the experimental value. So this will be 1.86 into 1, and T initial will be 0 and Tf is the final freezing point. So Tf will be now, the freezing point will be now minus 1.86 degrees centigrade. So it was found that 1 molar solution will be having a freezing point of minus 1.86 degrees centigrade. So this is an important point. So when you consider 2 moles of a solute in a given solvent, what is happening? When you consider 2 moles of solute, now molality will be 2, and similarly delta TF will be now 3.72, or final temperature, right? Delta TF is nothing but freezing point depression, and final temperature will be obviously 0 minus 3.72, it will be minus 3.72 degrees centigrade. So thus 1.86 is known as molar freezing point constant. So this 1. That's already discussed, we have already discussed that 1.86 degrees centigrade per molar solution is known as molar freezing point constant Kf. So do you know, students, do you know that some animals are able to survive freezing temperatures, right? How do you, right? If you just consider a sea or ocean, there are some animals, we consider fish or any animals, how can they sustain that high, that very cool temperature? They are able to survive because of this concept of freezing point depression. Why? Because some animals are able to survive freezing temperatures by producing antifreezes or substances that lower the freezing point of a liquid, right? So if initially it is 0 to freezing point is 0 degree centigrade, now it will be a lower freezing point. So that's why if they are producing natural antifreezes or the substances that lower the freezing point of liquid, they can now survive freezing temperatures. So in many freeze tolerant insects, the antifreezes are alcohols or sugars, right? So remember, antifreezes are alcohols and sugar are some of the antifreezes which helps against a freezing temperatures. So next concept. So here it's a graph. It shows that suppose you have a pure solvent. So this is a triple point equilibrium graph for a pure solvent. Right? This is a triple point of a solvent. So this is an equilibrium graph of a solvent, right? So plotted against pressure and temperature. So you have a triple point here. This is a solid phase, gas phase and liquid phase. Now if you are adding a non-volatile solute to the given pure solvent, what happens? You can see what is happening to the graph, right? So the new graph is now this one, this curve. Earlier it was this, now it is this blue color. So what is happening? The boiling point, right? The pressure will be 1 atm only. The the boiling point is the happens at 1 atm pressure only. So initially it was this, now it is this. So what is happening to the temperature? The temperature is increasing. Similarly, what is happening to the freezing point? Freezing point initially was this was the freezing point, now this is the freezing point. So the freezing point is decreasing, the boiling point is increasing, and what else you can understand? So this is the freezing point of the, this will be freezing point of the solution, this will be freezing point of the solvent, this is again the freezing point of the solvent, this is the freezing point of the solution. So freezing point of the solution, boiling point, this is the boiling point of the solvent, this is the boiling point of the solution. So boiling point of the solution is increasing, and here freezing point of the solution is lower than the freezing point of the solvent. So this is an important understanding of depression in freezing point and elevation in boiling point.
So students, we have seen the effect of addition of a non-volatile solute to a given solvent. So we have discussed about elevation in boiling point concept, we have discussed about depression in freezing point, which are two important colligative properties. There is also another third colligative property, which is osmotic pressure. So we will discuss about this property in our next part. Till then, stay tuned to our website www.askIITians.com. So have a good day, friends.